Good morning everyone. My name is Prasad Desai. Today, me and my group members Chandwadkar and Belge, we are presenting an information about a great mathematician, Dirichlet. So let's see the basic information. Dirichlet was born on 13 February 1805 in Duren, a town on the left bank of Rhine, which was a part of First French Empire. He was died on 5th May 1859 in Göttingen due to heart attack. He was a German mathematician awarded in PhD honors from University of Bonn in 1827. So let's now see about of Dirichlet. So Dirichlet was a German mathematician who made deep contributions of number theory, including creating the field of analytic number theory and to the theory of Fourier series and other topics in mathematical analysis. He is credited with being one of the first mathematicians to give the modern formal definition of a function. Although his surname is Dirichlet, he is commonly referred to as just as Dirichlet, in particular for results named after him.
Mathematical research. Number 1. Number theory. Number theory was Dirichlet's main research interest, a field in which he found several deep results and in proving them introduced some fundamental tools, many of which were later named after him. In 1837, he published Dirichlet's theorem of arithmetic progression, using mathematical analysis concepts to tackle algebraic problems and thus creating the branch of analytical number theory. In proving the theorem, he introduced the Dirichlet characters and L function. Also in the article, he noted the difference between absolute and conditional convergence of series and its impact in what was later called Riemann's series theorem. In 1841, he generalized his arithmetic progression theorem from integers to the ring of Gaussian integers. In couple of papers in 1837 and 1839, he proved the first class number formula for quadratic form, the formula which Jacobi called result, touching the utmost of human acumen, opened the way for similar result regarding more general number fields. Based on his research of the structure of unit group of quadratic fields, he proved the Dirichlet's unit theorem, a fundamental results in algebraic number theory. He first used the pigeonhole principle, a basic counting argument. In the proof of theorem in Defontine approximation, later named after him Dirichlet approximation theorem, he published an important contribution to Fermat's last theorem, for which he proves the cases n equals to 5 and n equals to 14, and to biquadratic reciprocally law. The Dirichlet's divisor problem, for which he found the first results, is still an unsolved problem in number theory despite later contribution by other mathematicians. Number 2. Analysis. Inspired by work of his mentor in Paris, Dirichlet published in 1829 famous memorial giving the conditions showing for which functions the convergence of Fourier series holds. Before Dirichlet's solution, not only Fourier but also Poisson and Cauchy had tried unsuccessfully to find a rigorous proof of convergence. The memoir pointed out Cauchy's mistake and introduced Dirichlet test for convergence of series. It also introduced the Dirichlet's function as an example of function that is not integrable, and in the proof of theorem for Fourier series, introduced the Dirichlet kernel and Dirichlet's integral. Dirichlet also studied the first boundary value problem for the Laplace equation, proving the unequiness of solution. This type of problem in theory of partial differential equations was later named in Dirichlet's problem after him. A function satisfying a partial differential equation subject to Dirichlet's boundary condition must have fixed value on the boundary. In the proof, he notably used the principle that the solution is the function that minimizes the so-called Dirichlet's energy. Riemann later named his approach to Dirichlet's principle, although he knew it had also been used by Gauss and by Lord Kelvin.
3. Introduction of the modern concept of function. While trying to gauge the range of function for which conversion of the Fourier series can be shown, Dirichlet defines a function by the property that to any x there corresponds a single finite y, but then restricts his attention to continuous function. Based on this, he credited with introducing the modern concept for a function, as opposed to the older vague understanding of a function as an analytic formula. Imre Lakatos cites Hermann Hankel as the early origin of this attribution, but despite the claim saying that there is ample evidence that he had no idea of this concept. For instance, when he discussed piecewise continuous function, he said that at point of discontinuity, the function has two values. Fourth, in other fields, Dirichlet also worked in mathematical physics, lecturing and publishing research in potential theory, including the Dirichlet problem and the Dirichlet principle mentioned above, the theory of the heat and hydrodynamics. He proved on Lagrange's work of conservation system by showing that the condition for equilibrium is that the potential energy is minimal. Dirichlet also lectured on probability theory and least square, introducing some original method and result, in particular for limit theorems and improvement of Laplace method of approximate related to the central limit theory. The Dirichlet distribution and the Dirichlet process based on the Dirichlet integral are named after him. He also received many honors during his lifetime. Some of these are Persian Academy of Science in 1832, St. Petersburg Academy of Science 1833, Göttingen Academy of Science 1846, French Academy of Science 1854, Royal Swedish Academy of Science 1854, Royal Belgian Academy of Sciences 1855, Royal Society 1855. This was all we know about Dirichlet. Thank you.